this leads us into simplifying radical expressions. Now, one of the big things that we saw during class, just to kind of reiterate here, if you have an even root and even power underneath the radical, you need absolute value in your answer. And we saw the reason for that during class, so I won't re-explain that here. So keep that in mind as we go through some of our examples, okay? And we'll do a couple examples right here, and then we'll have a B example to go with. So example 1A, really I'm going to do 3 examples within example 1A. Let's do the square root of 16x to the 8th. Okay. Now, we'll never actually need absolute values around numbers, so think of this piece by piece. Okay. The square root of 16 we can do, and that's 4. Now, this x to the 8th, how are we going to square root x to the 8th? Well, what times itself gives us x to the 8th? Okay, so you could think of x to the 8th as x to the 4th times x to the 4th. Now, some of these exponent properties we'll kind of have to remember here. If we take x to the 4th times x to the 4th, we add those exponents together. So the square root of x to the 8th is x to the 4th, like so. All right, but since we had an even root and an even power underneath here, we need absolute value around this whole x to the 4th. So I'm going to add a little note here. Absolute value, because even root and even power originally here. But there's an extra little trick. You guys are going to end up hating this whole absolute value thing. Because I have x to the 4th, I have an even power here. It doesn't matter what x is. Even if x was a negative number to the 4th power is still going to be positive. So I really don't need those absolute value bars there. So add my extra little note here, but x to the 4th is always positive. So including those absolute value bars would be kind of redundant. All right, so just kind of as a recap here, I had the square root of 16x to the 8th. The square root of 16 is 4. The square root of x to the 8th is x to the 4th. And we put our absolute value bars there because I had an even root. The square root is the second root, and an even power here. But because x to the 4th is always positive, I really don't actually need those absolute value bars. So that is my final answer. All right, let's do another situation. If I had the cube root of a to the 6th, b to the 9th. So cube root, what times itself again gives you a to the 6th? Well, a to the 6th is a squared times a squared times a squared. So the cube root of a to the 6th is a to the 2nd. B to the 9th is b cubed times b cubed times b cubed. So the cube root of b to the 9th is b cubed. And we don't need absolute value here because I had an odd root to begin. And one last example. If I had the fourth root of x, oopsies, the fourth root of x to the 8th, y to the 12th. Fourth root, what times itself? Times itself, times itself again. So x to the 8th is x squared to the 4th power. So what to the 4th power gives you x to the 8th? It's x squared. What to the 4th power gives you y to the 12th? It's y cubed. So the 4th root of x to the 8th is x squared. The 4th root of y to the 12th is y cubed. Now both of these, I have an even root and an even power underneath. Even root, even power underneath. So I need absolute value around everything. Even root, even power. But do we really need the absolute value around everything? This x squared is always going to be positive, so I really don't need it there. I really do only need the absolute value around the y cubed. So the x squared can be outside absolute value. Y cubed needs it still. And that is my final answer. So x squared is always positive. Don't need absolute value.